Hello, George Romanic here again. Today we have a very interesting problem. We are starting to mix different disciplines in physics and atmospheric sciences, physics in general. Problem, you can see it now on your screens. So basically we need to mix a little bit rotating reference frames in this problem with electrostatics and magnetostatics. Let's say we have electric field like this. Before I continue saying anything, I will just assume now you have certain basic knowledge about electric and magnetic fields. I still didn't cover that part of physics and atmospheric sciences on my channel, but I will in the future. So if we have electric field like this, and let's just assume that magnetic field is into the blackboard, so that would be like this. This would be magnetic field, uniform magnetic field, constant strength. There is no change of fields in time, hence electrostatics and magnetostatics. And now let's say we have a charged particle that is moving in this field like so. This charged particle has mass m and charge q. There will be force exerted on this particle, and that force is called Lorenz Force, and it is equal Q E, where E is electric field, Q is charge of this particle, plus V of the particle cross B. Now, the question says, find a rotating reference frame, non-inertial reference frame, that will cancel the effect of this magnetic force. Well, if I write second Newton's law for this particle, it will tell me that mass of this particle times acceleration, well, let's just write it in terms of total forces. That the total force of this particle on this particle will be these forces, Q E plus V cross B, but because now we are in a non-inertial reference frame, so this whole thing will rotate and we will measure velocity of this particle. This is velocity V. In that rotating reference frame, there will be two more forces, Coriolis Force and Centrifugal Force. These are apparent forces, and they will appear because now I start rotating this whole system. And I measure velocity in respect to that rotating coordinate system. Well, that means that F total will be Q E plus V cross B. Now, Coriolis force is negative 2m omega cross V. Now keep in mind, this omega is no longer angular velocity of Earth. It will be angular velocity of this rotating coordinate system that we are using to measure velocity. And we will have negative centrifugal force will be mass of the particle omega cross r, where r is radius vector between the center of rotation and this particle m. Of course, even from my previous videos, you know that if you introduce non-inertial reference frame, centrifugal force exists regardless whether or not particle is moving. Coriolis force only exists if the particle is moving. Okay, now notice something, that indeed this magnetic force looks quite similar to Coriolis force up to these constants Q and 2m. Okay, so we need this force to balance this force. Well, that means that Q V cross B needs to be equal but opposite of this. So this is Coriolis force minus 2m omega cross V, and this force needs to be equal to that but opposite. Okay. I can write this as Q V cross B is equal minus and minus will give me plus, but I will again put minus, and you will see why, because I want to reverse this cross product. And now look, this cross product indeed looks like this cross product over here. Therefore, omega as a vector needs to be negative Q times B divided by 2m. So, if I introduce non-inertial reference frame that has this angular velocity, the effect of this magnetic force over here will disappear if I measure them in that non-inertial reference frame. Well, Q and 2m are some constants, so we can see that omega needs to be, is proportional, let's say, to negative b. So that means if b was into the page, in this case, I have to introduce omega that is out of the page, and we usually use this to denote it. Well, I shouldn't use 2. I have to use omega, I have to introduce omega that is out of the page. And out of the page omega means counterclockwise rotation. Now, let's see if that makes sense. V cross B. V cross B. B is into the page. V cross B, my thumb is pointing in this direction. So that would be direction of magnetic force to the left of this motion. Now, what would be the direction of Coriolis force? Namely, where is it? Here. Omega cross V. Omega cross V would be like this in the same direction. So you might say, oh my God, you did mistake, but I didn't, because there is this minus over here. So omega cross V would be in this direction, but because of minus, it will go in that direction. So Coriolis force, in other words, Coriolis force would tend to deviate this towards the right, and magnetic force would tend to deviate this motion towards the left. If these two are the same, and they will be the same under this condition, then the effect is the effect disappears. Of course, it just disappears as a fictitious apparent process because we are introducing this non-inertial reference frame. Until next video, goodbye.